Okay, today is lesson 4, and we are going to talk about percent change. So we're going to actually start with a new formula that we're going to add to the few we've been using in the last week. So go ahead over to steps and things to remember, and we're going to write that formula in. So the first part of the formula is the word change. That's going to go over the word original. Equals % over 100. So the right side is staying exactly the same, and we're going to focus a lot more on the left side of our formula. So let's talk about the word change. The word change really just means to take the first value and subtract away the second value. And when you do that, you always want that to be positive. So if we're subtracting and we get a negative number, we're just going to take the absolute value of it so that it's always positive. And then the second thing that we're going to talk about is, what does the word original mean? The word original means the first value given. So let's apply this to a problem with just two numbers listed. So you'll notice the first top part of your notes are three problems that are percent increase. So we're talking about a number going from a smaller number to a larger number. And then when you look at the second half of your notes, another three problems. These problems percent decrease, or a larger number going to a smaller number. So we're going to start with increases first. Let's talk about the first problem, the number 40 to 45. So our first value listed is 40, and our second value listed is 45. So when I subtract those, I get -5. So like I said, it has to be positive. So since it has to be positive, we're going to take this absolute value, and we're going to find the change of 5. So this 5 represents just the change. We also have to find the original number. So the original number is just the first value given. So this 40 right here, this is our original. And I'm just going to diagram out this first problem so we know where we're putting these pieces into our formula. So we're going to take the change 5 over the original 40, and we're going to put our variable in the percent spot because we're going to find the percent in every single problem we're doing today. So the great part is that X is always going to go over 100 when you're finding percent change. That's not the case in the problems we did last week, so we have to learn to keep those two thoughts separate, right? So we've got 5 times 100 with the butterfly method, and then 40 times X. So that gives us 40X equals 500. We're going to divide by 40 on both sides of the problem to solve for the percent. And 500 divided by 40 is 12.5%. And so 12.5% is our percent change increase. Let's go to problem number 2. In problem number 2, Mitch earns $18,000 a year. After a raise, he earns $19,500. So again, we're going to take the first value minus, I'm sorry, that was not 18,500, that was just 18,000 minus 19,500. And that's going to give us a change of -1,500. But remember, we're finding its absolute value because it has to be a positive. So 1,500 is your change. The original is always the first number we see listed, or the first value, so $18,000 a year. So now let's write that proportion. So we've got our change of $1,500 over the original amount Mitch made, $18,000, equals X over 100. So butterfly method, we get 18,000 X equals 1,500 times 100. This is going to be a lot of zeros, so make sure you're being very careful when writing them. 150,000 We're going to divide both by 18,000. If you're like me and you don't want to type in a bajillion zeros, I like going in top and bottom and saying, all right, these pairs match, and these pairs match. So I can do the problem 150 divided by 18, and I get x equals 8.3%. Now, if you don't like crossing off zeros because you're unsure of yourself, go ahead and just type in 150,000 divided by 18,000, and you are still going to get the same answer. All right, last increase problem. You could pause this video, try it on your own, and then come back to it and see how you did. All right, so the sales of kids' sneakers rise from 1.5 billion to 2.8 billion. So we have our 1.5 and our 2.8. We want to find the percent increase. So the first thing we have to do is find our change. So 1.5 minus 2.8. And I can do that on my calculator. That's totally fine. Minus 2.8 gives you negative 1.3. Remember, change can only be positive, so we can take its absolute value to find its positive. So 1.3 is our change. And if you want to kind of like make your work kind of fit in, we can see right here that our first value was this 1.5 billion. So I'm just going to sneak that in there underneath that 1.3. Put my x over 100 and do my cross multiplying. So 1.5x equals 1.3 times 100, or move your decimal place 2 places to the right to get 130. And then I'm going to divide by 1.5, and that gives me a percent increase of, or x equals, and this comes out to 86.6 repeating. So I'm going to round this to 86.7 because that 6 would send it up to 7. And there is my answer. X equals 86.7% repeating. It is okay that you don't write the amount of zeros for the word billion as long as you use them both as decimal numbers. All right, so let's change modes and go to percent decrease. And guess what? You're going to use that same formula. So the only other thing that's not going to happen is you're going to be subtracting and you're not going to get a negative. So no absolute value thought on this. We're just going to take that first number, or that first value, minus that second value. So 140 minus 77, and you get a change of 63. So it's positive here. So you just go right into that listing. That original number or original value is 140, and you get x over 100. So we cross multiply and we get 140x equals 6,300 when you multiply by 100. And you divide by 140, and you're going to see a percent decrease of 6,300 divided by 140, and you get a 45%. And this is a decrease. All right, let's go to a word problem. Last year, Anthony earned $24,000 after a brief layoff, meaning he left his job or was told he couldn't work. His income decreased to $18,000. We want to find the percent change of his income. So we take that first value, 24,000, minus that second value, 18,000, to get the change of $6,000. We take that $6,000. Remember, we're looking for the original amount he made. So that was 24,000. And then on the right side, x over 100. So we get 24,000. Be careful with your zeros. X. And then this has 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. You could do it that way, the strategy. So that's 60,000 or 600,000. Divided by 24,000. Again, I like matching up my zeros top and bottom. So that becomes 600 divided by 24. and get x is equal to 25%. So go ahead and see if you can figure out the third one. Pause the video. And then you could see how you did by playing it back. This one's a little wordier. A poll of 1,000 voters conducted by the staff of Senator Chun found 522 people approved of the job. This year, a new poll of 1,000 voters shows that 423 people approved of him doing his job. And we're going to find the percent change. Is it a decrease or an increase? So there's kind of a second piece to this problem. So let's do our change first. So we know that the original value or first value is 522 minus the second value of 423. So that's 99 people difference, or 99 change. The original value was the first amount of people that voted. So 522 equals x over 100. So we get 522x, and then we have 99 times 100, which gives us 9,900. And we divide by 522. And that gives us a percent change of 18 point, and I'm going to write this all the way through, 9655. So we're doing any kind of rounding. When we look here, all those numbers are going to send the next number up. So this would be wise to just say a 19% change. The other question asked is it an increase or a decrease? We have to look at the original problem. If 522 people originally said yes, great job, and then 423 said yes, great job, this would be a decrease because the numbers went down. Okay, so hopefully that explains the formula you're going to use. Change over original equals percent over 100, and you are able to work through the 10 practice problems below.